Okay, an open top box is to be made um, from square shaped cardboard. So what we are given, these pieces are H. That's the spot where we are going to cut, right? To fold it and make the box, open top box, right? The whole this side is, let's say, 60 centimeters. Okay, and this side A, let me check different. This is our side A, that it's going to be equal X because it's unknown. We're going to mark down as an X so we can solve it and find out. So our task is with how deep this cut here we need to do. This cut here, how deep cut we need to do to maximize, get the maximum of the volume from the cardboard. So because the bottom of this box, it's gonna be square, right? Because this cardboard is cut as a square. Then the volume of this box is gonna be A squared H, right? Okay, it's like square type box. So the volume is gonna be square of the bottom, which is square will be A squared, and times our height. Okay, since we have A is equal, X, right? Then I can write down that H is gonna be equal 60 minus X, since I have two H's there, so I have to divide by 2 because this, and plus this H is same, right? So dividing by 2, and from here I'm substituting as an H in this calculation of volume. V is equal, it's gonna be X squared times 60 minus X divided by 2. All right, and from here we are going to have, so I'm going to put 1/2 represent as a 0.5, and here will be 60x squared minus x cubed, right? Where our x is going to be greater than 0, less than 60. Let me move this down. Y is going to be greater than 0, less than 60. Because if I open here, 60x squared, 60x squared minus x cubed, I am going to take x squared out, and I will have 60 minus x, right? If I assign as a 0, so either x is equal 0 or x is equal 60. So it has to be between, x has to be between the 0 and 60. Okay, now, since we have the formula for the volume, so how we're going to get the maximum volume? How do we know which volume is going to be the maximum? So first of all, we are going to take derivative and then find the maximum of that derivative, and that will be our maximum volume. Okay. So what I'm going to do, first of all, I'm going to take derivative of v prime. It's going to be at dv by dx, right? v prime, it's going to be equal 0.5 and 120 x minus 3x squared, right? I took derivative of this expression, right? And it's going to be equal 1.5x 40 minus x. Okay, now let's find critical points, right? So critical point is going to be for this the variable x, and for the our derivative. So from here I'm going to find critical point, and critical point is going to be when v prime is equal 0. When v prime is equal 0, that means from here I can figure it out that either x1 is going to be 40, right? Or x2 is going to be equal 0. And this 0 obviously cannot belong to, that does not satisfy this 0 or 60, right? Oh, x1 I said 40. Okay. All right. So this way we have only one critical point 40, because x2 is equal 0 doesn't fit to this condition. X is greater than 0 and less than 60. It cannot be equal 0 or 60. So it's going to be 40 practically. So here is we go. This is my line. Okay, this is my 60. This is my 0, empty circle, because 0 or 60 is not included. And here is going to be, let's say, middle 30. Here is going to be, let's say, somewhere here, it's going to be 40. So let's see what critical point it is. Is it maximum or it is minimum? So I'm going to figure it out. So I'm going to plug V of 40. I'm going to find out V of 40, because 40 is our critical point. I'm going to write down V of 40, and I will have. So I am plugging to our formula for V, this one. Okay, let me plug. We are going to get x squared. It's going to be 1600, right? Multiplied by 60 minus 40 divided by 2, and I'm getting 16,000. Okay, now we need to figure out this 16,000. It's going to be either maximum or minimum. How we are going to figure it out? So I'm going to take, let's say, value below 40. Let's assume I'm taking, for testing, I'm taking here 30, right? Let's go back to our primary equation. Where is it? Oh, here is our with yellow color. See that? Okay, because we are plugging, this is our V prime, right? Therefore, we are plugging to our V prime in here, right? Let me clean this with yellow shade. So if I take 30, then it's going to be positive, correct? 40 minus 30 is going to be positive. 1/5 times 30 is positive. So result is going to be here positive, which means When on interval we have plus, that means the function is increasing, correct? There we go. That's how you explore derivatives. Now let me take the value between 40 and 60. Let's say I'm taking 50 here. If I take 50, the expression with the yellow shaded, 40 minus 50, it's going to be negative right there, right? Even though 1.5 times 50 is going to be positive, but parentheses is going to be negative, which means this interval is going to be negative, decreasing. When a point is changing from positive goes to negative, that means we are dealing with maximum, which means I can write down here V maximum is equal V of 40 and equal 16,000 cubic centimeters, right? Okay, so what we can say from here, so if we have 16,000, then our height is going to be how much? Our height is going to be 10, right? Let's see. 60, here is our age. Let me write down. Age is equal. Let me this one change the color so we can see this is one answer. And then age is equal 60 minus x over 2, right? So our age is 40, so it's going to be 60 minus 40 divided by 2 is equal 10 centimeters, which means the max, V max, it's we can get when a is equal 40, x is equal 40, which is a is equal 40 centimeters, and age is equal 10 centimeters. So if you ever need to cut some box, well, you can calculate. And V max at this point, it's going to be 16,000 centimeter cube. Okay. All right.